Right, last class kita tengok until unequal variance. Population variance unknown, and where we have condition variance is assumed equal, right? So yesterday kita tengok variance assume equal for unknown variance. So the formula will be we need to multiply with pool standard deviation, right? For yesterday, kan? So for today, we're going to look into another condition where the population variance unknown, right? Population variance unknown, but we assume the population variance unequal, right? So when the population variance unknown and assume unequal, right? So the T distribution will be x bar 1 minus x bar 2 minus mu1 minus mu2 divided by sample variance sample variance number 1 divided by sample variance number 1 and plus for number 2 and taking the square root for everything, right? But in this case, we need to calculate the degree of freedom. So as compared to previous one, when we assume population variance equal, the degree of freedom is equal to N1 plus N2 minus 2. Right? This is from yesterday, kan? So for today, the degree of freedom, this is degree of freedom, V, is equal to uh, sample variance divided by N1, sample variance number 2 divided by N2. And then this one, we take with power 2 and divide by the same thing divided by N minus 1, right? So this is a degree of freedom for population variance unknown and assume unequal, right? Okay. So basically the concept are same as previous, but the formula that we use is different, right? So this is a confident interval for population mean, difference of population mean, for population variance unknown and assume unequal, right? It's the same procedure, but if you look at this one, this is a standard error. The standard error from yesterday, we just use pool standard deviation, right? But for this one, S1 square divided by N1 plus S2 square divided by N2. This is a standard error, right? So if you multiply with the critical value, it becomes margin of error, right? So if you multiply with this one upon critical value, so it become margin of error. This whole thing is margin of error, right? So the degree of freedom we calculate based on the formula, right? S1 square divided by N1 plus S2 square divided by N2 divided by everything divided by square root of S1 square divided by N1 square divided by N1 plus minus 1. And that is a formula, very long formula. So now let's look at the example, right? Example number 21. Two companies manufacture rubber material intend for use in automobile application. So 25 samples of material from each company are tested. So the amount of wear after 1,000 cycle observed. So company one, sample mean and standard deviation. For company one, sample mean and standard deviation is given as this one. So X bar 1 is equal to 20.12. Standard deviation is 1.9, right? For company number 2, standard X bar is equal to 11.64 and standard deviation equal to 7.9, right? So in this case, the population variance unknown, right? And we have a very small sample size and is less than 30. So we will use T distribution, right? So now read the following instruction. Do sample data support claim that two companies produce material with different mean where? So we want to see whether mu1 equal to mu2 or mu1 not equal to mu2. So we use alpha 0.02. Assume each population is normally distributed but unequal variance, right? So we know that this condition in this statement, we don't have equal population variance. So now let's state the null hypothesis. So null hypothesis will be mu1 minus mu2 equal to 0. Another one is alternative hypothesis, mu1 minus mu2 is not equal to 0. Right. So basically the original hypothesis will be mu1 equal to mu2. This is not equal to mu2. So we can manipulate, we become mu1 minus mu2 equal to 0. And this one not equal to 0, right? So alpha in our case is alpha is 0.02. And test statistic. So since the population variance are unknown and we assume unequal, right? And the sample size is very small. So we use t distribution, x bar 1 minus x bar 2 minus mu1 minus mu2 divided by S1 square divided by N1 plus S2 square divided by N2. And we take a square root for here. Because this is supposed to be a standard error. So this is a standard error, right? Okay. So this one should be equal to the value of mean 1, sample mean 1 is 20.12 minus the mean average for population company number 2 is 11.64 minus 0. So where do we get 0? From here, right? Mu1 minus mu2 equal to 0. So divide by the standard deviation for company number 1 is 1.9. Oops. 1.9 square divided by N1 is equal to 25. Another one is what is a 7.9? 7.9 square divided by 25. And we take it as square root. So this one should be equal to 5.22. Right? 5.22. Right. Next, once you already calculate the test statistics, then we need to find the critical region. So critical region, based on the alternative hypothesis, it should be two-sided, two-tailed test, right? So two-tailed test, we're going to have two rejection region, right? One on the right-hand side, another one is on the left-hand side. So the critical value here should be T alpha divided by 2 with degree of freedom. And this one should be negative T alpha divided by 2 with degree of freedom. Right? So our degree of freedom is 0.02. Right? So T 0.01. 0.02 divided by 2, 0.01. And the degree of freedom. So we need to calculate the degree of freedom. Degree of freedom is S1 square divided by N1 plus S2 square divided by N2, and then with power of 2, everything, divide by S1 square over N1 square plus, divide by N1 plus minus 1, S2 square over N2 square divided by N2 minus 1. So this is the formula for degree of freedom. So this one should be 1.9 square over 25 plus 7.9 square over 25, right? And we take we power 2 here. And then this one 1.9 square over 25, and we square this one, divide by 24. 25 minus 1, and plus 7.9 square divided by 25, and then we square this one, divided by 24, right? Okay, so you calculate this one, it should be equal to 26.77, right? 26.77, but if you look into your statistical table, we don't have decimal point, so this one should be equivalence to 26 lah, right? Or you can take 27 as well, should be okay, right? So the degree of freedom here should be T alpha 0.01, and degree of freedom is equal to 27, right? So use statistical table, look at T distribution. This is Z distribution, table number 2. T distribution 27, right? 27 here. Alpha is 0.01. So 0.01. So it should be this column. It should be 2.473. So this is 2.473. Right? So this critical value on the right hand side is 2.473. On the left hand side will be negative 2.473. And of course, in the middle should be equal to 0 lah. And this is T distribution from negative infinity to infinity. Right. So next procedure, we need to find we need to make a decision. So since the T calculated, so what is the value of T calculated? 5.22, right? 5.22 is more than T alpha divided by 2 with degree of freedom, which is 2.473. Null hypothesis is rejected, right? Another way to understand this, so this is 2.47. So our T calculated is 5.22, lies inside rejection area. So we reject null hypothesis. And of course, we need to acknowledge this one, rejection area. And this is also rejection area. And this is acceptance area. Okay? Boleh? Right. So conclusion, what is our conclusion? Since we accept alternative hypothesis, it means that mu1 is not equal to mu2 lah. So we have enough evidence to support that mu1 is not equal to mu2. Okay? Boleh faham? So basically, it's the same procedure but different formula based on the different condition lah. Okay? Boleh? Can you try example number 22? This one done, right? Sudah? Can you try example number 22? So in example number 22, we have two company, X1 and X2, right? Company 1, company 2 lah, right? So, so dia kata apa dekat sini? Test the hypothesis that average running time of film produced by company 2 exceed the average running time produced by company 1 by 10 minutes. Right, by 10 minutes against one-sided alternative that the difference is less than 10 minutes. So use alpha 0.01, assume the distribution is approximately to normal distribution and unequal variance. So in this case, right, so N1 we have 1, 2, 3, 4, 5, N2, 1, 2, 3, 4, 5, 6, 7, right? N2 we have 7. So you just find the value of standard deviation and mean. So I'm going to use calculator. So choosing statistics, number 6, right? So I'm using 2 for 2 variable, right? Let's say X is X1, Y is X2. So I input a value 102, 86, 98, 109 and 92. So we have 5 observation for X, and for Y we have 7, right? Can you try? Use calculator a bit fast, huh? So if you have this kind of question in final exam or test, better use calculator to calculate, right? So in this, by using this calculator, you can recheck back your data imputation, right? Right. So once you already enter the data, click option and choose number 3, which is 2 minus variable calculation. So you will get all the statistics. So X is X1. So X1, X bar 1 is equal to 69. Is it 69? Dapat betul ke? Sama? Betul? Try salah tulis. Betul lah. Right, 69.57. X bar 2 is equal to XY bar, which is 110. 110. Okay. And S1, so let's find S1. S1 is equal to this one, SX, right? SX is equal to 48. 48.076, right? And then we need to find SY. SY is equal to 30.22. S2, 30.22. Okay? Boleh? So next, since we already have the important point data, so we state our null hypothesis. Null hypothesis is mu 2 minus mu 1 more than or equal to 10 lah. Mu 1, null hypothesis, mu 2 minus mu 1 less than 10. Right. And we are using alpha equal to 0.01. Okay. So in this condition, n is less than 30, population variance unknown, right? So from here, we already know that we're going to use t distribution, but another condition we have is unequal variance, right? So we're going to use t distribution with calculated degree of freedom. Okay, so this one is t equal to x bar 1 minus x bar 2 minus mu1 minus mu2 divided by S1 squared over N1 plus S2 squared over N2. So this one should be 60. Oh, terbalik lah sebab dia nak measure mu2 minus mu1, right? So it should be X bar 2 minus X bar 1 mu2 minus mu1. So this is 110 minus 69.57 minus 10 divided by square root of S bar S square. So 48. We take 48.008 lah square divided by N1 is equal to 5 plus 30.22 square divided by 7. Right. So what is the value of T? Right. Dapat yang sama? Sama ke? I baru calculate, maybe salah. Sama. Alright, good. So next we need to find the critical region. So in this case, we based on the null alternative hypothesis, this is a one tail test, right? So one tail test. So the rejection area should be on left, right? Because this is a less than on the left, right? So the critical region, the critical value is negative T alpha with degree of freedom. So this is 0, T from negative infinity to infinity. So T alpha is equal to 0.01 and the degree of freedom. So we need to calculate the degree of freedom. df is equal to S1 squared over N1 plus S2 squared over N2, and we take squared here, divide by S1 squared over N1 square N1 minus 1 plus S2 squared over N2 square over N2 minus 1. So we plug in the value. S1 square is equal to 48.08 square over 5 plus 30.22 square over 7, and square here, divide by 48.08 square over 5, and we square it here, divide by 4 plus 30.22 square over 7, and we square, divide by 6. Right? Can you calculate? This one is equal to 592.801 divided by lupa nak square. So what is the value or degree of freedom? Dapat tak? It should be 6.244. Dapat sama? Right. 6.244. So equivalent to 6 lah, huh? Right. So this one should be T 0.01, 6 degree of freedom. So this one should be 0.01, 3.143, right? So it should be 3.143. Okay? Boleh? Soalan? Any question? So we make a decision. So since T calculated, is less than, so this is negative 3.143, right? So T calculated is equal to 1.25. So this is less than, right? Negative T alpha with 6 degree of freedom. So this one should be null hypothesis is accepted. Okay. So since null hypothesis is accepted, we don't have enough evidence to support mu2 minus mu1 less than 10. Right? Okay? Boleh? Boleh? Ada soalan? Any questions so far? Right. So now, if you don't have any question, then we move to example number 23. So, example number 23. Wait, So, according to example number 13, right? So, still remember example number 13? We don't have here. Example 13, yesterday, kan? So 14, 13. Oh, yesterday kita tak tengok kan example 13. Right, it's okay. So a sample of 15 1 pound jar of coffee brand 1 shows that the mean amount caffeine is 80 milligram. Right, with standard deviation 5 milligram. Another sample 12 pound brand 2 with mean equal to 77 and standard deviation equal to 6. So we want to construct 95% confidence interval for the difference between mean amount caffeine in 1 pound of these two brands. So we assume these two populations are approximately normal distribution and standard deviation of two populations are not equal, right? So let's extract the information. So brand 1 and brand 2. So brand 1, we have N1 equal to 15. N2, we have N equal to 12, right? X bar 1 is equal to 80 and standard deviation S1 equal to 5. X bar 2 is equal to 77, S2 equal to 6. So we want to construct 95% confidence interval. Right. So the the formula for confidence interval is probability of X bar 1 minus X bar 2 plus minus T alpha divided by 2 with degree of freedom and standard error X1 square divided by N1 plus S2 square divided by N2. Right. Okay. This is should be equal to 95%. Okay. So we just plug in the value into the formula. So X bar 1 is 80 minus 77 plus minus T alpha 0.05. Right? In this case, alpha 0.05. How do we know? We want to construct 95%. The balance will be 5%. So 0.05 divided by 2 with degree of freedom multiply with standard error. Right, this is 5 square over 15 plus 6 square over 12. Right. Okay. So now the only value that we don't have is the t value, right? So we need to calculate the degree of freedom. So S1 square over N1 plus S2 square over N2, and then we square here. Should be S1 square over N1 square divided by N1 minus 1 plus S2 square N1, so N2 square over N2 minus 1. So if you plug in the value, it should be 21.42. So it should be equivalent to 21. So we need to find T 0.025 with degree of freedom equal to 21. So this one should be equal to 2.080, right? So later you cari nanti lah the value. You calculate the degree of freedom, right? So you just plug in the value. This one should be 80 minus 77 plus minus 2.080. And if you calculate this one, it should be 2.16024,690, right? So the confidence interval will be from negative 1.49, right? 7.49 equal to 95%. So this is the probability of mu1 minus mu2 from negative 1 until 7.49. So since the 0 is inside the interval, means that mu1 is equal to mu2. There are no significant difference. Okay. All right. Any questions so far? No question? Boleh faham, right? Can you understand, son? Right. For example number 24, I think you can do by yourself, right? Yeah. Conclusion, there are no significant difference because mu1 minus mu2 should be equal to 0, right? So 0 is inclusive in the interval. Right? So example number 24, 25, 26 until 27, I think you can do by yourself, right? Provided you understand previous example. Okay, boleh? Right, let's look at another case, which is test about difference between two means. So after this example, this section, then we take 5-minute breaks, okay? So this is a very short lecture for case number 3. Test about different two means, right? Large sample. In this case, we still under the condition where the population variance unknown. I still remember yesterday the diagram that I draw for you. Right. Look at the diagram again. So we are looking into hypothesis about mean, right? And we already looked into population known. Now we are looking into population unknown, right? But the sample size are more than or equal to 30, which is large sample size. Right, so we're going to use Z distribution. Right, so Z distribution quite straightforward. So if you have unknown variance, right, but a large sample, right, so the Z distribution, the test statistic will be x bar 1 minus x bar 2 divided by minus mu1 minus mu2, s1 square divided by n1 plus s2 square divided by n2. So this is a Z distribution, right? So if you have now alternative hypothesis not equal to, this is two-tailed test, and in this one more than or less than, this is one-tailed test, right? For two-tailed test, we need to divide by 2 for degree of freedom. So you don't have a degree of freedom, alpha divided by 2. For one-tailed test, we just take alpha, right? So this is a confidence interval, mu1 minus mu2. So we take the standard error is s1 square divided by n1 plus s2 square divided by n2. We take a square root. This is a standard error. So if you multiply with the critical region, critical value, so it becomes margin of error. Okay. Don't forget to sign in your attendance today. Right. So now let's look at example number 28. So a study want to investigate if mean price of a new proton car has changed in 2012 compared to 2011. A sample car was taken during 2 years and summary information below lah. So this is the mean price, standard deviation of car price in 2011, and this is the sample size, right? So X bar 1 equal to 45,000. S1, so this is a standard deviation, right? So 1,500, and N1 equal to 1,150. X bar 2, 48,000. S2 equal to 2,000, and 2 equal to 200. So in this case, the population variance unknown, right? We don't know the population variance. And if you look at the sample size, it's more than 30, right? So we're going to use Z distribution, Z statistics. So perform test above for the above investigation. What is your conclusion, right? So we want to know whether the mean price have changed in 2012 or not changed. So null hypothesis mu1 minus, so equal to mu2. Alternative hypothesis mu1 is not equal to mu2. So this is also equal to mu1 minus mu2 equal to 0. Mu1 minus mu2 is not equal to 0. And alpha equal to 0.05. Test statistic. We are using Z distribution, right? X bar 1 minus X bar 2 minus mu1 minus mu2 divided by S1 square divided by N1 plus S2 square divided by N2. We take a square root. So this one should be 48,000. Sorry, X bar 1 is 45,000, right? 45,000 minus 48,000, right? Minus 0. Mu1 minus mu2 is equal to 0. Divided by 1500 squared over 150 plus 2,000 square over 200. So this one should be equal to negative 16.04. Okay. right? Next, we need to find the critical region. So based on the null alternative hypothesis, the critical region is, we have two tail tests. So we have two side critical rejection region. So this is acceptance region. This is rejection region. Right? So the critical value is negative Z alpha divided by 2, and this is Z alpha divided by 2. Okay? So Z alpha divided by 2 is equal to Z 0.025. Okay, so this one should be equal to 1.96. So this is 1.96 and negative 1.96. Right. So the value of 1.96 we already discussed yesterday, kan? So our decision here is, since Z calculated, so what is the value of Z calculated? Negative 16, right? Is less than negative 16 point, less than negative Z alpha divided by 2. So null hypothesis is rejected. Okay. So negative 16 somewhere here lah, negative 16, right? So it lies inside the rejection region, 16.04. Right. So our conclusion is, so the mean price of car in 2012 has changed significantly as compared to 2011. Okay, done? Sudah? Right. So let's look at the second question, which is find two-sided 95% confidence interval for the difference between two means in 2011 and 2012. What is your conclusion comparing with part one? So now, B, the 95% confidence interval, so it should be x1, x bar 1 minus x bar 2 plus minus z alpha divided by 2, and the the standard error is x1 square divided by n1 plus s2 square over n2, right? So this is equal to 95%. So you just plug in the value into the formula. So probability of x1 bar, s bar 1 is 45,000 minus 48,000, right? Plus minus 1.96. This is 1500 square over 150 plus 2000 square over 200. Okay. Boleh, eh? So this one actually same as yesterday. I just compress it into one line. It should be look like this: x1, x bar 1 minus x bar 2 minus z alpha divided by 2 s1 square over n1 plus s2 square. So this is a full formula, right? So I compress it into the short one. Okay. So once you input the value into the formula, you will get probability of negative 3366.67. 1 minus mu2. It should be negative 2633.32. Equal to 95%. So since mu1 minus mu2 equal to 0 is not in the interval, so then we reject null hypothesis. It means that there is a significant difference lah. Okay. So basically, this topic is easy topic lah, but you need to understand which test statistic to use under which condition. That's all. The procedure are same from single population until two population. The procedure all same. Okay, boleh? Any questions so far? No question? You want to see more another example, or you want to take 5-minute rest? Huh? No response. 5-minute rest you got. Okay, example number 29, I think you can do by yourself. It's the same as example 28, right? So we take 5-minute rest and then we go for test for two proportion. Okay, boleh sambung? Can we continue? Right. So the last part for chapter number 8. Right. But remember, your quiz will be on this Friday, 8 a.m. I think 8 a.m. 8:30, I think. 8 p.m. Yeah. AM or PM? Okay, 8 until 8:30 p.m. This Friday, 20 minutes. Should be online using YouLearn. Okay. Right. Test for two proportion. Yes. Subjective. Right. No objective. But you need to calculate lah. But it's very easy question, right? Chapter number 5 and chapter number 6. Chapter number 5 is joint probability distribution, right? And chapter number 6 is random variable, random sample, a sampling distribution. Okay? Is it? Chapter number 5 is, oh no, chapter number 5 is joint probability distribution. Chapter number 6 is random sample and center limit theorem. Right. So test for two proportion, right? So we already looked this one in chapter number 7, right? For one proportion, for two population, if you have two proportion, so we want to use a test statistic Z distribution, P1 hat minus P2 hat divided by the grand P multiply with Q, this is Q hat, multiply with 1 over N1 plus 1 over N2. So P1 hat is equal to X1 over N1. P2 hat is equal to X2 divided by N2. And the grand P hat is equal to X1 plus X2 divided by N1 plus N2. Right, so Q hat is equal to 1 minus P hat. Right, so this is when the P1 is equal to P2, proportion 1 equal to proportion 2 lah. So this is the alternative hypothesis. We want to test whether P1 equal to P2 or P1 is not equal to P2, whether proportion number 1 more than proportion number 2 or proportion number 1 less than proportion number 2. So this is a one-tail test. And this is two-tail test. Right? So we're going to use Z distribution. So this one should be very easy lah. Then the confidence interval, right? It should be proportion number 1 minus proportion number 2 minus with the critical value multiply with the standard error, which is P1 Q1 divided by N1 plus P2 Q2 divided by N2. So this is a standard error. Everything is, if you multiply with critical value, it become margin of error. Okay. So this is the confidence interval for difference between two proportion. Right, let's look at example number 30. So in this section, I have 7 examples. Right, but I think I'm not going to go through every example, just 1 or 2. Right. So in a study on the effect of sodium restrict diet on hypertension, 24 out of 55 hypertensive patients were on sodium restricted diet. 36 out of 149 non-hypertensive patients were on sodium restricted diet. So we want to test the hypothesis that the proportion of patients on sodium restricted diet is higher for hypertensive patient, right? So let's say proportion 1, we have x equal to 24 and x1 is equal to 24 and 1 equal to 55. Proportion number 2, x2 equal to 36 and 2 equal to 149. So proportion P1 hat is equal to 24 over 55, which is equal to how much? 24 divided by 55 equal to 0.436. Is equal to 0.44 lah, huh? So P2 hat is equal to 36 over 149. So this one should be equal to 36 over 149. 0.2416, 0.24. Q1 hat is equal to 1 minus P1 hat. So this one should be equal to 1 minus 0.44, 0.56. And then Q2 hat is equal to 1 minus 0.24. So this one should be 0.76, right? We just collect the data dulu, right? So P1, the grand P hat is x1 plus x2 divided by n1 plus n2. So this one should be 24 plus 36 divided by 55 plus 149. So this one sama dengan should be equal to 0.30, right? And the Q hat is equal 1 minus P hat. 1 minus 0.30 equal to 0.7. So you just pick up all the data that we have. And we try to perform hypothesis testing. Right? The null hypothesis is equal to P1 equal to P2. Alternative hypothesis, P1 is greater than P2. Right? So it says that patient with higher for hypertensive, P1 is higher lah. So alpha equal to 0.05, test statistic. So this is a proportion case. So we are using Z test, P1 hat minus P2 hat, right? Divide by PQ hat 1 divided by N1 plus 1 divided by N2. Right, and then we take a square root here lah. It's so supposed to be standard error. So this one's 0.44 minus 0.24 divided by the grand P is 0.30 multiply with 0.7 multiply 1 over 55 plus 1 over 149. So don't worry, the formula will be given in final exam, right? So this one should be equal to 4.9455. Can you confirm the value? 4.9455? Is it same? Dapat sama? Dapat? Tak dapat? Dapat berapa? Zero point 2.766. Right? Okay? Boleh? So I just need to take note this one. 2.766. Right, semua dapat sama kan? 2.766. Right, so then we need to find the critical region. So since this is more than, so it's a one tail test. So the rejection area should be on the left or right? Should be on the right side. Because this is more than, right? So this is Z alpha, right? But we have only one tail test, so Z alpha. So Z 0.05 should be equal to 1.645. So you know how to get the Z 0.05, right? So look into the statistical table, okay? So our decision here is, since Z calculated equal to 2.766, which is more than Z alpha, null hypothesis is rejected. So we can conclude that, conclusion, we have enough evidence to claim that the proportion of patients on hypertension is higher than non-hypertension. Right? Okay? Huh? Belum? So this is by using critical value approach, kan? So how to use p-value approach? So p-value approach should be, this is a one tail test on the upper tail, should be 1 minus probability of Z less than Z calculated. Right? So remember, Z calculated always positive value, right? So 1 minus probability of, in this case, should be positive value. So probability of Z less than 2.766. So look at the statistical table, 2.766, 2.76 lah, huh? 2.76, this one. Should be 0.9971. So 1 minus 0.9971. So it should be equal to how much? Should be 0.0029, right? So since p-value is less than alpha 0.05, right? Null hypothesis is rejected. So this is by using p-value approach. So the conclusion are same as this one, right? Any questions so far? Ada soalan? No question? Easy, right? So next question is construct 95% confident interval, two-sided, and comment. So I'm using this color. So C, we want to find 95% confidence interval for two proportion. So the probability of P1 minus P2 hat plus minus Z alpha divided by 2 multiply with P1 Q1 divided by N1 plus P2 Q2 divided by N2. Right? So this one should be 95%. Okay. So you just plug in the value into the formula. So P1 minus P2, 0.44 minus 0.24 plus minus Z alpha is 1.96, right? So alpha is 0.05, right? So divide by 2, 0.025 is equal to 1.96. So multiply with 0.44 multiply with 0.56 divided by 55 plus this is 0.24 multiply with 0.76 divided by 149. Okay. So if you calculate correctly, it should be equal to probability of 0.052 P1 minus P2. P1 hat, huh? And this one should be 0.348. So since P1 minus P2 equal to 0 is not in the interval, right? Null hypothesis is rejected. So means that there is a significant difference between P1 and P2. Boleh? Any questions so far? You want more example? More? Right. So let's look at example number number 32. So I think 31 you can do by yourself, right? So let's look at example number 32. This is also a same example, right? Same concept. Right. So in nursing home study mentioned in chapter opening, statistic today, the researcher found that 12 out of 34 randomly selected small nursing home had resident vaccination rate less than 80%. right? While 17 out of 24 randomly selected large nursing home had vaccination rate less than 80%. So at 95% level of significance, test the claim that there is no significant difference in the proportion of small and large nursing home with resident vaccination rate less than 80%. So first step is we collect all the data, small and large. X1 is equal to 12 and 1 equal to 34. X2 equal to 17 and 2 equal to 24. So P1 hat equal to 12 over 34 equal to 0.35. P2 hat is equal to 17 over 24 equal to 0.71. Right? Correct? So Q1 should be equal to 0.6. 0. What? 65, right? .65. Q2 should be equal to 0.71. 0.29. Right? And then P hat, the grand P, x1 plus x2 divided by n1 plus n2. So this is 12 plus 17 divided by 34 plus 24. So this one should be equal to 0.5. And Q hat is also equal to 0.5. So we just collect the data first, right? Now we want to perform hypothesis test. State the null hypothesis, proportion number 1 is equal to proportion number 2. Null alternative hypothesis, proportion 1 is not equal to proportion 2. So we want to test at 0.05, 95% level of significance, right? So test statistics, the Z value should be P1 minus P2 divided by P hat Q hat multiply with 1 over N1 plus 1 over N2. And we take a square root. Basically, this one should be minus P1 minus P2, right? By right lah, but because P1 minus P2 is equal to 0, P1 minus P2 is not equal to 0. This is same, right? So it should be 0.35 minus 0.71 minus 0 divided by square root of 0.5 multiply with 0.5, 1 over 34 plus 1 over 24. So this one should be equal to negative 2.70. Can you confirm this one, this value? Dapat? Negative 2.7, right? Okay, good. So next, we need to find the critical region. So based on the null alternative hypothesis, so this test is two-tailed test because the alternative hypothesis P1 is not equal to P2. So we're going to have two rejection area on the left hand side and right hand side. So this one is 0, negative Z alpha divided by 2, Z alpha divided by 2. So since alpha 0.05, Z 0.025 is equal to 1.96. So this one is 1.96 and this is negative 1.96. Okay. And our decision is, since Z calculated is less than negative Z alpha divided by 2. So negative 2.7 somewhere here, right? It lies inside rejection area. So null hypothesis is rejected. Okay. So since we reject null hypothesis, we conclude based on alternative hypothesis. So there is a significant difference Okay. So this is the conclusion. Boleh letak kat bawah lah. Can put here. All right. That's all. Okay. Any questions so far? Boleh? Soalan? No question? Belakang? All right. I think this is example number 32, right? So now let's look at example number 34. This is the last example for today, right? Example number 34. We want, based on example number 32, we want to find 95% confidence interval for the difference of proportion of the data. So first step, let me copy all the information. Copy all the information first. Right. Then we plug in the value into the formula. So what is the formula? Probability of P1 hat minus P2 hat plus minus Z alpha divided by 2 multiply with the square root as standard error P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2, right? So this one should be equal to 95%. Okay, so we plug in the value into the formula. So P1 hat is equal to 0.35 minus 0.71 plus minus Z alpha divided by 2 is equal to Z 0.05, 1.96. So 1.96 multiplied with the square root of P1 is 0.35 multiplied with 0.65 divided by 34 plus 0.71 multiply 0.29 divided by 24. This is 95%. So the probability, the confidence interval will be negative 0.602 P1 minus P2 until negative 0.118. So since 0 is not inclusive in the confidence interval, there are significant difference between proportion 1 and proportion 2. We reject null hypothesis, we accept alternative hypothesis. Okay? So I think for example number 35, 36, 37, you can do by yourself lah. This one done, huh? Conclusion. Right juga kah? Ada simpan pen. Alright, since 0 is not in the interval, the proportion number 1 is not equal to proportion number 2. So either you conclude the first one or second one lah. Dua-dua boleh. Okay. So don't forget your quiz number 2 this Friday, 8 p.m. to 8:30 p.m. online. You learn. Okay.